This is Team 404NameNotFound, and this is our project final report. For question generation, we followed a similar format to Howman and Smith in their overgeneration and ranking procedure. We first shove the text through a parser, pre-process it to make it prettier, generate the questions, post-process, and rank it, and then output our best questions. So for pre-processing, what we aim to do is iteratively remove detailed descriptors we know we can do without, such as parentheses and positives and the like. Once that is done, we continuously reparse whatever is left, and then we run it through co-reference resolution so that we have fewer ambiguous questions, and then we generate potential answer phrases we can remove. An example is shown on the right. So for question generation, we do this in two major ways. Like I said before, we take the answer phrases, remove them from the sentence, use supersense data to tell if we use who, what, when, where, etc. And then we also manipulate the sentence purely syntactically to get whatever things we want. Examples are shown on the slides.
After question generation, we send the questions into post-processing, which purely exists to make the questions possibly harder to answer. And the first step of this is synonym or hypernym, or synonym and antonym substitution for nouns and adjectives respectively, followed by some hard-coded phrase replacement, such as is something an apt descriptor for something else, replaced by is something an accurate or inaccurate descriptor. And then finally, we have ordinal number replacement, for example, replacing third with second or fourth, and adding not before the main nerve for our binary questions. And after the post-processing, we finally send the questions to the ranker. This ranker primarily considers two things, which is just the type of the question that we generated, such as who, what, binary, or other types, and also the length, which we try to keep around 14, since that removes any overly simplistic or overly specific questions. And some secondary characteristics that we've included in the ranker are tree depth, the number of S-bars contained in the parse tree, and the specificity of the nouns, which basically just means how many proper nouns and how far nouns are away from the entity root in WordNet, which we use to try and weed out questions that were improperly formed during the question generation.
So for the answer generation part, here you can see this is over the overall flowchart. The original article is parsed to find the most relevant sentence, and we classify the input questions, and using the classified input question and the relevant sentence to generate the potential answer. So for finding the most relevant sentence, we use a sentence embedder called %, which is published by Facebook Research in 2017. So after each sentence is embedded, we use the cosine similarity to find the sentence with minimum distance compared to the embedded question. So the original question is classified into 5 different types, as you can see. Binary questions: what, who, which, where, when, how many, why, and how. This is done by simple keyword matching. For either and or questions, it's split into 2 binary questions. So how we deal with binary question is, first we take the original question and we format it to assertion format. So this is done using Stanford constituency parser, which is find the leftmost constituency and switch it with its right neighbor. After the question is reformatted, we extract all the non-verb, adjective, and not keywords into 2 sets. And for each keyword in set 1, if set 2 contains the exact or synonym of this keyword, all the keywords, we consider those 2 sentences semantically equal. So the output is yes, or vice versa. And for either or questions, as I said, the original question is split into 2 binary questions. So we output formal or latter based on the matching result respectively.
For WHN questions that focus on subjects and objects, we use the dependency tree to find the main verb and the main subject in the relevant sentence that match those being asked in the question. Depending on the corresponding position of them, we then extract the noun chunk either before or after the main verb in the relevant sentence to be the answer. We use a combination of dependency tree and named entity recognition to answer WH-ADV question, such as where, when, and how many. We identify the noun phrase with the matching and year tag. If there are multiple ones, the noun chunk that's closest to the main verb in relevant sentence is the answer. For why questions, we use the keyword-based approach, where we find the sentence after specific keywords such as because, and then extract the sentence from the keywords to the next punctuation to be the answer. How questions are answered using constituency tree and dependency tree together. Finding the verb in the relevant sentence that matches the main verb in the question, we examine if there exists ADV mod, ADV clause, or prep for the verb in its dependency tree. If yes, those would be the answer. Otherwise, we will search the entire parse tree using DFS and then choose the ADVP as the answer. Thank you very much.